Hello everyone, welcome to the course Data Analysis with Python. In this course, we are going to study three major libraries Numpy, Pandas and Matplotlib, and we are going to discuss how we can develop multiple projects with the help of these three libraries. These projects can help you in development of your professional and practical career. The first thing that we are going to discuss is the installation of software. We are going to install Anaconda and we are going to discuss what are its IDEs and how it can be used. After that, we will move on to Numpy library and we will discuss what are the type of arrays that are used, what is slicing, and what are the main Numpy operations. Later, we are going to discuss about Pandas library, and in that we are going to discuss how we can read datasets in that, how we can develop dictionaries, and what are the ways for file handling in Pandas. The third library that we are going to study is Matplotlib. We are going to discuss how we can make simple plots through it, how we can make area plots, how we can make histograms, bar charts, and how we can make pie charts with the help of Matplotlib. So to get it started, let's start with installation. To install Anaconda, you should go to anaconda.com/downloads. From here, you can install your Windows installer, or you can change it to your MacBook or your Linux based system. So let's get it started. So it is already downloaded in my system. That's why I am going to cancel this. After downloading it, you will run it and you will complete the installation. After installing it, what you need to do is you need to open Anaconda Navigator. Now as you can see in the navigator, there are multiple IDEs. In your case, a lot of them will not be present. You will need to pip install them. I will show you how you can do that, but before that, let me show you how you can create your own environment. You need to click on environments and you can create a new environment from here by clicking create and by naming the environment. So that's how you can name any environment, and later you can install packages into that environment. Now that your environment is created, you can just close the Anaconda Navigator and you can come to Anaconda prompt and you can activate your environment by writing conda activate. And for my case, I have already developed an environment, so I will write SWAD here, but you can make your own environment and run it here. So as you can see SWAD here, which is my environment. Now I can install Numpy and Pandas in it by using pip install pandas. As you can see, the requirement is already satisfied, so it did not do anything. The second one is pip install numpy, so it is also present. And the third one is pip install and matplotlib, so it is already present. That's why all of these showed that requirement already satisfied, but in your case they will be downloaded. After that, the next thing that you need to do is you need to install Jupyter Notebook. Jupyter Notebook is the IDE that we are going to use. When you install Jupyter Notebook, then after that what you need to do is you need to open Jupyter Notebook. You will just write here Jupyter Notebook and you will open that. I have already done that. So this is the Jupyter notebook when it is opened. So from here you can make a new file, but I have opened an already developed file from here. So this is the first step, the installation process. After that, the next step is Numpy. So Numpy is a Python package. It stands for numerical Python. It is the fundamental package for scientific computing in Python. It is the Python library that provides multi-dimensional array objects, various derived objects, and a collection of routines for processing of array. So basically Numpy is just like simple arrays, but they are a lot better and a lot faster. That's why Numpy is used in a lot of cases. So we can just start by importing Numpy as np. What it will do is it will make an object np of the type numpy. Later, whenever we want to use the attributes of numpy, we will just write np.array or something like that. So that's how you can just import numpy package into your system. So after running it, the next thing that we are going to do is we are going to make a 1D array. So let's write 1D. For the 1D array, let's write np.array array, and let's put in a round bracket. After putting in the round bracket, let's just write a square bracket in it so that it makes it an array or a list, and we can just write something like 10, 20, 30, and this will be our first one-dimensional array. So after that, we can also show that array by just writing a, and it will show us that your array is 10, 20, 30. It has basically 3 elements. So you can of course also use the print command if you want to do the same thing, and it will show you that 10, 20, 30, these 3 are the values that are present in the array. Now if you want to take any of those elements and print that element, you will do that like this. So this is how a simple array is made and its members are taken into account. Now let's talk about two-dimensional arrays. In the same way, we can develop a two-dimensional array by writing it inside np.array. So to do that, let's write np.array, and in here let's write three-dimensional array. So let's say the first dimension is 10, 20, and the second dimension is 2, 3, and the third dimension is 5, 4. So this is how you can make a three-dimensional array. Let's see what is the error here. Yes, to make a multi-dimensional array, we need another brackets outside this so that it makes it a list of 3 elements. This will be the first, this will be the second, and this will be the third element, and inside that there are 2 elements in each element. So this is how the multi-dimensional array works. Okay, so let's just print it out and let's see. Now this is the three-dimensional array. In this you can see that the first element is 10, 20, the second element is 2, 3, and the third element is 5, 4. So in the same way, we can make two-dimensional arrays or 5-dimensional arrays or another type of array, whatever we want. Now let's move on to array attributes and array types. We are going to see a couple of attributes. The first attribute is the shape of the array. Okay, so this is your array X. Let's run it, and now let's call the shape function. So this is how you can get the shape of the array. In this shape you can see that you have three rows. This is the first row, this is the second row, and this is the third row, and there are two columns. So the element 2, 5 and 10 are in column 1, and elements 3, 6 and 20 are in column 2. In the same way, we can also change the shape of an array. Let's write how you can do that. Let's say we take another variable x1, and we say that x1 is equal to x. After that, what we do is we write x1 dot shape. So the previous shape was 3 cross 2. Let's just change it to something like 2 cross 3. There we go. And then let's print x1. So the shape is changed. Now the rows are columns and the column are rows. It has taken the first three elements and it has made it the first row, and it has taken the last three elements and it has made it the second row. So this is how you can also change the shape of any array that is present. You can also check the size of any array by just writing array.size. This is how you can check the size of any array. The size of our array is 6. It has 6 elements, 1 2 3 4 5 6. So this is how you can check the size of any array. Through Numpy, we can also create a range of numbers that are equally spaced. To do that, let's take another variable x3, and the function that is used for that is arrange, and in that we write the maximum range of that. So let's print out x3. So this is it. The first number is 0 and the last number is 9, which comes just before 10. If we change it to something like 14, then it will start with 0 and it will end with 13. We can also skip some of these numbers. Let's suppose if we want to skip 1, 3, 5, 7 or vice versa. We can do that by slicing the array. But before slicing the array, we need to tell it what is the starting and what is the ending point. So let's suppose s is equal to slice, and in this slice we have the starting point, the ending point and the difference. Let's just make this 10 to show it more better. So this is the slice, and after slicing it, what we can do is we can just print out the array x3 with s slices. So let's see what it gives. So there we go. We have 1, and after 1 it is skipping 1, and then it is giving us 3, and then it is skipping 4 and giving us 5, and then it skips 6 and gives us 7. So this is how the slicing works. It works from 1 to 9, and there are 2 element jumps. So in the first element it will go to the second element of that. So it will not print out the first element after that, but the second. So the first element was 1, and after that the element that came was 3. If we put 3 here, we can see that it printed out 1, and after printing 1 it skipped 2 elements and showed us 4, which was the third element after 1, and after that it skipped 2 elements and showed us 7, which was the third element. So this is how we can also perform slicing on any array that we want. Let's now talk about a few of NumPy operations. The first operation that we are going to discuss is median. That gives us the median of whatever array that we have passed. Let's first copy paste the X array, and after that let's just write B is equal to np dot median, and in median what we are going to do is we are going to pass X, and after that let's print B. So there we go, 5.5 is the median value between all of these values. This is how we can use the median function. Other than median, there are a number of other functions that we can use as well. For example, mean, average, variance, and standard deviation. Let's do that one by one. Let's first do mean. Let's first do mean. So for that you just have to write mean here, and it will tell you the mean of the complete array that was present. And after that we can also check the average. The average function shows us the average of all of these values. The mean and average gives us the same result because these are the same things. We can also check variance, and we can also check standard deviation. So these are the main basic operations of NumPy that we have discussed, and by using these operations we can perform a lot of manipulation on arrays. So now let's move on to the main part of our course, which is Pandas library. Pandas is used a lot when we are talking about data analysis. So data analysis is the domain of working with data to get clean, useful information, which can then be used to make informed decisions. The complete set of data analysis revolves around identify, and then we collect, and then we clean, analyze, and interpret. For all of these things we use Pandas library. Pandas is an open source Python library designed to deal with data analysis and data manipulation. The main data structure is in Pandas is a two-dimensional table called data frame. So we are going to create the data frames, we are going to import the data frames, and later we are going to use the data frames. So let's get into it. The first thing is we need to install Pandas, but we have already done that through command prompt, so I'm going to skip this step. The next part is to import Pandas, so let's do that. So this is how you can import Pandas as PD, and after that we are going to read a dataset that is already available in the folder that we are currently working in. So the dataset that we are going to discuss first is weather dataset, and in this dataset there are multiple columns such as summary, temperature, humidity, wind speed, and we are going to use data manipulation to develop better insights from these datasets. So let's read it first. To read a Excel sheet you need to write read underscore CSV. Let's click it. There we go. Now the file is present in the variable D, which is now a data frame. Let's write df because df is normally used. Now we can Okay, so I think I did not run it, maybe. Okay, so this is it. So this is the data frame, the Excel sheet that we have. These are the formatted dates. This is the summary. This is the temperature, apparent temperature, humidity, wind speed, wind bearings. So all of these columns are available. We are going to perform data manipulation on this data set now. Before going into many detail, I wanted to show you one or two of the functions of data frame. After that, we are going to get into data manipulation. So the first function is df.head. It is very important when we are talking about data analysis, but because sometimes we need to see only upper part of our data frame. So it will show us the first three rows. There we go. It is showing us 0, 1, 2, 3 rows. In the same way, we can also write df.tail and also tell us how many rows do we want to see. So we want to see 2 rows. So it is showing us the last 2 rows, which are these. So these are the last entries. Okay, so this is how you can perform the head and tail function here. After that, the next step is how you can get any 2 rows of your own choice from this dataset. To do that, what we need to do is we need to tell it which rows do we want to pick. Let's suppose we tell it that we are going to need row number 7 and 8, 7 to 8, which makes it one row, and if we pick 7 to 9, then we are picking 2 rows, 7 and 8. So this is how we can pick multiple rows from a data frame. Let's suppose we write 200 and 205, then it will pick 1, 2, 3, 4, 5 rows from 200 to 204. So this is how we can access them through the number of the row. We can also access them through this particular indexing of each column. Let's suppose if we write temperature here, let's just copy paste it from here so we can not make any mistake, and we run it, and this is what the whole column of temperature gives us, from 9.4 and it ends to 20.4. So this is how we can pick a column from a data frame, and this is how we can pick any row from a data frame. So we can also show you the head or tail of this temperature part. For that, what we need to do is we need to write it like this. So it will only show us the head. If we want to see only 2 rows, then it will show us 2 rows. So this is how we can show the columns and rows of any data frame. We can also get the minimum and maximum value from the same data frame by taking whatever column we want and just writing minimum maximum after that. Let's suppose if we want to have minimum value from this, we will write minimum function. So it will give us the minimum value of temperature that is present in that column. We can also put out a maximum value from any column. So this is how we can display the maximum value from that data frame. Other than that, we can also show the correlation between any 2 particular columns. So to do that, what we need to do is we need to take one column and we need to write the command .corr, which states the correlation, and after that we need to take the next column. Let's take the next column as apparent temperature, and this is the whole name of the column. Let's take that. So this is the simplest way that you can perform maximum, minimum value operations as well as the correlation. Correlation is a very important parameter, as later it becomes more apparent that the parts of the data frame or the data set that are more related with each other have a better or positive correlation, and the parts of the data set that are not related to each other, or they are not that much same or similar, those have very low values of correlation. So correlation serves as a very important metric when we are talking about data analysis. There are a lot of other parameters as well, like mean absolute error and MAPE, but we will not be discussing them today. Now we will move on to conditional statements in a data set. In any data set, the conditional statements tell the values in which the conditions hold true. Let's assume we need to find the temperature when apparent temperature is minimum. We need to find the value of the temperature in which apparent temperature is minimum. Let's just copy this part and paste it here, and after that let's just copy this part like this and save it inside a square bracket. And now we are going to give it the condition. So the condition is we need to only monitor those temperature values when apparent temperature is at its minimum. So when the value of apparent temperature is minimum. So let's discuss it for a minute. The first thing that it will do is it will take the apparent temperature data frame part and it will compute the minimum value, and then it will see if the data frame value is equal to that minimum value, and if that is true, then it tells us that it is true. So this is how this works. So therefore it will show us the temperature at which the value of apparent temperature is at its minimum. So let's run this. So this is the temperature at which the apparent temperature has the minimum value. For example, let's suppose if we want to see that what is the temperature at which the apparent temperature is at its maximum. So we will just write this one, and this is the value of temperature at which the apparent temperature is at its maximum. So as you can see, it can help you during data manipulation and during checking whether your data is working fine or not. So there is another thing that we can see. For example, we can see that what is the relationship of visibility or what is the value of temperature when the visibility is minimum, or what is the value of temperature when the visibility is maximum. So let's copy this and let's paste it here. For maximum, let's just copy the visibility part and let's just paste it here. There we go. So it will show us what is the value of temperature when the visibility is at its maximum. So these are the values of temperature when the visibility is at its maximum. We can also see the minimum value as well. So these are the values of temperature at which the visibility is at its minimum. So this is how we can see how different columns of each data frame are related to each other, what are its relations, and how they are unique from one another. So using correlation and using minimum maximum functions, we can do a lot of manipulation of data. We are going to explore it further in the projects that we are going to discuss at the end of this video. Those projects will show you how you can develop your own data analysis skill set with the help of practical problems. So now let's move on. If we talk about any data frame, there are a lot of values that are NaN. NaN means not a number. So these are the values that are present in each data set. There are a lot of ways in which we can make these values better. We can replace them with zeros, we can replace them with average values, or we can do a lot of other things. For example, if we want to, we can fill the NAs in this data frame with the value 0. In the same way, we will be using it with an average out function. So this is how we can fill the NAs that are present in each data set by any specific value. We can write 0 here, we can write 1 here, we can write 2 here. If we want, we can make a function that takes the average of above and below values, and then we can replace that with the current value here. But we are going to discuss that in our project series. Now let's move on towards creating our own data frames. We can create our own data frames with the help of dictionaries. So these are very easy. We just need to call the data frame and pass the dictionary as an argument to the function, and it will help us develop the dictionary that we want. Before doing that, let's just take a dictionary, my friends, and in that let's just say that we are having 3 or 4 different columns. Let's say the first column is date, and in the date column we have 3 or 4 dates. I will just copy paste this part. Let me just take it out of my blog and paste it here. Like this. Okay, so as you can see, the first one is date. In the date there are 1 2 3 4 5 different dates, and this will be the first column. The second column is 1 2 3 4 5 different names of friends, and these are their ages, and these are the numbers. So we can use this dictionary and make it a data frame. For that, what we need to do is we just need to write, let's do it in another cell. We need to write, let's just run it first. Okay, so for that, what we need to do it, we need to write df is equal to pd.dataframe. Data frame, f is big, I always forget it, and we can just write my friends in it. So it will make it a data frame. Now let's run this, and as you can see, this is now the new data frame that we have developed. In this data frame, as you can see, we have 1 2 3 4 different columns. The first column is date, the second column is names, the third column is age, and the fourth column is number. So now let's just check out the shape of this data frame that we have just developed. So there we go. This is the shape of the data frame. We can also access any member of that data frame in the same way that we used to do before. So let's access the attribute date or the column date. This is the date column. We can also access 2 or 3 of the columns together. For that we need to make a list within list. So let's say we write date here and we write names here. So that way we can access 2 columns. So this is how we can access columns, and I was supposed to write it here. Let's just delete that. Okay, so now let's see how we can access rows. We have already done all of this. I am just trying to show you that dictionaries work fine when they are developed into data frames. So this is the first row, and we can take more than one rows. Let's suppose we take 3 rows here. Okay, so this is how we can take rows, and this is how we can take in columns. Now let's take another few functions of data frames. Let's write df.describe. What describe does is it shows us different attributes of that data frame. So if we talk about age and number, their counts is 5, their mean is this, their standard deviation is this, their minimum value is this, their percentiles are these, and their maximum value is this. So here only those columns will be included which have numerical values in it. So if we go back to our data frame, this is the column number 1 and this is column number 2. Only these 2 columns have the numerical values present within them. So this is how we can do that. We can develop a data frame or create a data frame through our own dictionaries. Now let's move on towards changing indexing. Pandas has its own indexing by default from 0 to row number. We can also reset its index by set index function, or we can reset the index as well. For example, if we want to change the index of this data frame, let's just write the data frame again first. So this is the data frame. Let's now change the index of this data frame. Right now the index is 0, 1, 2, 3, 4, and let's suppose we want to make the index age. What will we do then? Okay, so for that we need to use df.set_index, and we will write age here, and after that we will write in place is equal to true. That this in place parameter makes sure that no new object is created and the previous object is used. Okay, so now let's see our data frame. So there we go, age is the index now. Other than this, there are a lot of other things that we can do with our data frame that helps us later. For example, we can take out any part of the data frame with the help of the command df.loc. Let's take the date parameter, or maybe let's just enter the bigger data frame that we had, so that we may be able to see it even better. Let's just say that there we go. Let's bring it here. Let's do that, and let's make an index of summary from there. Okay, so now let's see df. This is the data frame in which the summary is this one. The first one is partially cloudy, then there is mostly cloudy, partially cloudy. So this is the complete summary, and these are all of the other columns. Right now the thing we can do is we can take any of this row and we make a group out of it. For example, if I say that find out wherever mostly cloudy is located, it will take out all of the values that has mostly cloudy in it. To do that, what we need to do is we need to write df.loc, and in that we are going to write mostly cloudy. Okay, so let's run this. So this is all of the information on mostly cloudy. We can do the same on partially cloudy as well. So there we go. It is showing us only those values that have partially cloudy in them. So this is one way to get a group value out of the data frame. Another way is through location. For example, I can also tell it that I need whatever thing is available at position 1. So it gives me a value that this is the temperature at position 1, this is the apparent temperature, this is the humidity. So this is all of the information that was available at row number 2. Let's suppose I can change it to 2 or 3 rows as well. Like this. So there we go. In this way we can also get to our particular rows that we want, the particular data that we want. So to reset the index at the end, what we are going to do is we are going to write df dot reset underscore index, and that will make sure that our index is reset after that. So summary is here and the index is the same now, 0 1 2 3 4. Okay, so this is how we can perform data manipulation with pandas. After this we are going to read and write files through pandas, but I wanted to take a little time to discuss this part with you. This is the main part. We can take our own columns or our own rows that we want. We can also take a particular type of data out of the whole data frame, and later what we will do is we will take this data frame and we will perform something on that and visualize it so that we can drive insights through this data. So this is all this course is all about, and in the projects we are also going to do the same thing to make sure that you understand completely the importance of data analysis. Okay, so I was supposed to write here like before, but I didn't, so let's delete it again. So the next part is reading, writing in the Excel files. So as we know, the reading part is very similar. Let me just copy paste it. So this is how we can read a file. I have done it before. It is pd.read underscore csv and dataset slash weather.csv. So this is how we can read any file. So for that the file should be CSV file, If we want to read the Excel file, there is another Excel file also available here. The name of Excel file is Titanic. As you can see, this is Excel file, as this is CSV, this is CSV, this one is Excel. So now we are going to enter the Excel file. For that, there is only one change, that we write Excel here. Let's make a new cell. I always find that there are less cells that we can work in. Okay, so anyways, so this is how we can read the Excel sheet, and the name of Excel sheet was Titanic, and the extension of Excel sheet is XLS. So okay, so it is giving us an error. Let's see what this is all about. Let's see the error. Okay, so yeah, it is telling us that Xlrd is not installed. So Xlrd is the library that is used to read Excel files. So let's do that before. So pip install. The name of the library is Xlrd. So let's install it, and then we will be able to read the Excel sheet. So there we go. As you can see, now we are able to read the Excel sheet, and we can use it as a data frame as we did before. So if you want, you can also read specific part of the Excel sheet as well. Let's suppose you want to read the number of rows, which is 7. So then it will read only the first 7 rows. You cannot actually see it in the head, but if I delete the head part, you can see that there are only 7 items, 7 rows that are available here. So in the same way, we can also ask it to not read the NaN values. Let's suppose if we want, what we can do here is, to do that, what we need to do is we need to write NA underscore values is equal to none. That way it will not read the NaN values. I do not recommend using this way, but you can also do that if you want. Okay, so these are the simple ways in which you can read any Excel or CSV file. If you want to create your own file, then what you can do is you can just write data frame, which was D, to CSV, which will create a file from this data frame to CSV, and let's suppose we want to use the same folder, and we write the name of the file as AI underscore studio. Okay, so that way the file will be saved here, and as you can see, its name is AI studio. So this is how you can save a file into your system. You can also create a new Excel file with the help of Xlwt library. For that, we need to install the library first, and then we can just take it to the Excel sheet as well, just like CSV. So let's just write the same thing here, but AI Studio underscore Excel. Okay, so that will create a file AI Studio underscore Excel. So this is the main part of pandas. I have told you everything there is to know about pandas for now, and in the next part we are going to discuss about matplotlib, as well as we are going to use the insights that we can take from pandas, and later we can visualize those insights with the help of matplotlib. So this is how all of this works. In the first stage, we derive the insights through pandas and numpy, and in the second stage we show them or we visualize them with the help of matplotlib. Okay, so now let's start the next part. Our course, which is data visualization. Data visualization has a lot of libraries in Python like Matplotlib and Seaborn, and all of these libraries are good enough to perform data analysis, but the library that we are going to focus on is Matplotlib. Matplotlib is a functional library that is an extension of NumPy, and the one of the core aspects of Matplotlib is matplotlib.pyplot, which is the scripting layer which we studied in details in the Matplotlib video. Other than that, we can create figures, graphs, line plots, histograms, pie charts, all of these things by using Matplotlib. So let's get into it and let's see how that is done. Before doing that, before getting into Matplotlib, what we'll do is we will do a little bit of modification in our dataset so that it performs better. Okay, so let's just read the dataset first. Let's just say that df is equal to pd.read underscore csv, and the name of csv is datasets slash weather dot csv, just like before. Let's run it. Okay, it is saying that the name pd. Okay, so I haven't imported everything again. Let's cut this, let's paste this, and let's say import pandas as pd, and then let's run this again. Okay, so after that let's just see the head of the dataset once again. So there we go. This is the head of the dataset. There is a formatted date here. There is summary, temperature, apparent temperature. We have added another column, formatted dataset, in this so that visualization is a lot better. So let me show you the columns too. These are all the columns of the data frame: formatted date, summary, precip type, temperature, apparent temperature, humidity, wind speed, wind bearing, visibility, loud cover, pressure, and daily summary. So let's suppose if we want to see what is in the data frame at at formatted date. This F is bigger, I suppose, and then we are going to write head here and just like this. So this is the complete formatted date column that is present in this data set. So we can also see the tail of this by just writing df formatted date dot tail. We have done a lot of that before, so I am going to skip that. And one last thing that I am going to show you is that we can also do the eye location. So let's suppose if I want to get a small part of dataset out of this and make sure that I can use that dataset later. So for that, what I will do is I will write df1 is equal to df dot iLocation, and from 0 to 100, what it will do is it will take the location 0 and up to that location 99, and it will make sure that all of those rows are saved where in the data frame df1. So this is what we are doing, and the reason for that is so that our we can visualize the graph a better way, so it does not looks very much complex. We will also get into complex graphs later, but for now we are going to consider only 100 values, 100 rows, you can say. Okay, so in this, the first type of plot is line plot. So to do the line plot, the first thing that you need to do is import pyplot from Matplotlib. So to do that, we will write import Matplotlib from Matplotlib import pyplot as plt. So this will make sure that we are importing pyplot from Matplotlib library, and it will be imported as plt. So we will be using plt from now on. Okay, so let's just do a small plotting now. Let's just write df1 dot plot here, and let's suppose we want to make sure that the kind of plot is line plot. Then we will write this here, and on the x-axis, what if we need dates versus temperature? So if we want dates versus temperature, what we need on x-axis is the date. So we will just write it for mated date here, and then we are going to write temperature here. So the column temperature, let's just copy paste that so that we do not make any mistake. Okay, so this is the temperature column. Okay, so let's paste it here, and after pasting it, let's run this. So to plot it, we need to write plt.show. So this is the plot that we got from this data frame, in which we plotted dates versus the temperature. So there are a lot of other things that are present in a plot, which are legends, axis labels, title, and figure size. So now we are going to enter all of those things. So now let's enter all of those things into mix. To do that, the first thing we need to do is we need to copy this cell and we need to paste it here. After pasting it here, the first thing that we are going to enter is the figure size. So figure size is a parameter that is entered here. Let's suppose if we want the figure size to be something like 10 cross 6, then we will write figure size is equal to round brackets 10 cross 6, just like this. So this is how you can give figure size to your graph. Other than that, if we want to make sure that the grid is on at the back, as you can see, there is no boxes at the back here. So if there are boxes here, then the graph looks a lot better. So to do that, what we need to do is we need to write grid is equal to true, and that should be right here. Other than that, the next thing is, what if we want to plot multiple things right here? If we have temperature, what if we want to also plot apparent temperature or something like humidity? For that, what we need to do is we need to make it an array. In the array, the first variable is, the first feature is temperature. The second feature is apparent temperature. For example, let me just copy paste it. And the third feature can be something like humidity. So you can just add as many features as you want in the y-axis or even in the x-axis as well. So this is it. We have added three features here. Now df1 plot should show you three different features in the y-axis. So what about labels now? So for labeling, the first thing that we need to do is we need to enter a title here. That will be the title of the graph. So to enter the title, we need to write df.title, and in this title we are going to write something like weather overview of. So w, after w we will write weather for 100 days. This will be the title of the graph. After this, the next thing that we can write is the y label of the graph. Sorry, we need to write plt.title. So in the same way, we will write plt.x label, and we will write it as value, and we will write plt.y label, which we will write as date. After this, we need to show the graph by writing plt.show, and this will show us the graph. So there we go. This is the graph for three different features. All of these features are listed here. First one is temperature, which is the blue one. Second one is apparent temperature, which is the orange one, and this is the humidity. These are the values, or I think we have written it wrongly. So this was the date and this was the value. So let's run it again. So these are all the dates and these are all the values. So this is how you can plot any graph, any line graph that you want, and you can also give it a lot of information like legends, grids and things like that. So we have seen now that how you can use multiple features and plot it in the line graph. I was supposed to write it above, but let's start now with the bar graphs. So in the bar graphs, the difference is we have bars or histograms of data. So first, to do that, let's just make a bar graph of only 5 values. df1 dot head and 5 values, and then let's just plot val dot plot, and the kind of plot will be bar. But before that, let's just tell it that the x is the formatted date. So formatted date, just like before. Let's use these apostrophes this time. Okay. And what is y? Let's just write y is equal to, and I will copy the whole array from above. Y is equal to temperature, apparent temperature and humidity. So let me just copy it and paste it. Okay, so what is the kind of graph? The graph is of kind bar, so bar. And other than that, what if we want to give it a figure size? So the figure size can be something like 10 comma 5, just like before. And let's also make sure that our grid is on, because that looks a lot better. Okay, so this is vl.plot, and then after this let's just write the same title and same x and y label, just like before. Okay, so there we go, this is it. Let's just run this and see what we get. Okay, so this is the graph that we got. We have three different things: temperature, apparent temperature, and humidity, and we have taken only 5 dates. If we want, we can take as many dates as we like. So this is how we can plot any sort of graph in the form of bars. As you can see, this gives a better understanding, or a different type of understanding, than the line graphs. The next part is we can also stack these graphs together. Let's do that now. For example, we have three plots, and what we can do is, to do that, first let's take all of this and equalize it to a variable. Let's suppose the name, oh sorry, we do not need this one. Let's suppose the name of the variable is ax is equal to vl.plot, and then all of the same data. Now after this, what we can do is, we can we can show all of these data together in one bar. For example, if we are talking about the first bar, what we can do is, we can show this, that this one is for humidity, and then until this one there is apparent temperature, and after this one there is temperature. But we will know that this is the upper limit of temperature, this is the upper limit of apparent temperature, and this is the upper limit of humidity. So to do that, what we need to do is, we need to use this plot and make sure that we are making a different plot for apparent temperature and another plot for humidity. So first I wanted to show you how it is different from our previous values, that's why I did this. So let's say that the temperature is present here, and after this what we can do is, we can write val dot plot, and in this one we can just put the same things as before, with a difference that we do not need figure size now, as well as the grid. But the thing that we are going to do is, we are going to change the color for sure. So the default color will be for temperature, and for this one the color should be something like C2, or before that what we need to do is, we need to write here that the axis is equal to the ax, which is the graph that we plotted before. So this is how we are going to make the stacked graph. The ax is going to remain here, and it will be equal to the axis inside the parameters of each graph, and the color is something like green. So for green the code is C2, So let's write C2 here. In the same way, we can also copy it and use it for humidity, and the color should be C3 here. Sorry, C3. Let's copy the apparent temperature and paste it here, and let's copy the humidity and paste it in the third row. So then we will be all good to go with our stacked graphs. After this, the next part is to sort of do the labeling and plotting. Okay, so to do that, we will just copy paste whatever we did before and see if it runs or not. So it is giving us an error. Let's see what it is saying. Invalid color C2. So it is saying that C2 is not a color. I think it should be in upper letters maybe. Okay, so there we go. This is how we can do the stacked graph, but this is not right. Let me see what is wrong here. Okay, so let's see what is happening here. Okay, so no, we have this graph right here. So this is the stacked graph for temperature, apparent temperature and humidity. I don't know why this one is showing. I'll look into that. But this is the stacked graph. In this you can see that temperature, apparent temperature and humidity, all of these things are shown on the same bar. So this is how we can develop histograms as well as bar charts with the help of Matplotlib. So there are a few other type of graphs that are very much used in a lot of data visualization techniques, and those two graphs are area plot and as well as pie charts. So now we will discuss about them. Okay, so next one is area plot, and to do the area plot, first we need to drop a few columns from our data frame, and then we will plot the area for that data frame. So let's write df.drop and let's see what needs to be dropped from here. So the things like wind speed, this one, and visibility and cloud cover, these are all the things that we do not need for the area plot that I have thought about. So we are going to drop all of these values. So let's just do that, and we are going to give the axis 1 so that columns are dropped, and we are going to write in place is equal to true, which means that the object is the same, no new object is created. So it is also very important. So this is how we are going to drop specific columns from our data set. Okay, so after that, let's just see df1 dot columns. So all of those columns are deleted now from here. After this, let's do the area plot now. So from the complete data set, we are going to take only 5 values. So for that, let's write df1 dot head and take its 5 values, and then we will write plot, and in the plot we will write kind. What is the kind of the plot? It is area. And is the area plot stacked or not? No, it is not stacked, so we will write false here. After this, we will give it a figure size. So the figure size will be something like 10 comma 5, and let's give it a title and label now, and let's see what it does. Okay, so let's see what it does. So this is the area plot. Here we have three things. This is the temperature, this is the ambient sorry, this one is the temperature in the upper limit, this one is the apparent temperature, and this one is humidity. So this is how you can develop area graphs. We can also do something like dimming this area graph so that it looks a little better. That does not make much of a difference, but it does make it look a little better. So for that we give the value of alpha is equal to 0.25, and let's run this again. Okay, and it is saying that you have an error. Okay, so let's see. I have written, oh my god, the spelling of alpha are incorrect. Anyways, so this is how you can dim it, and this is the way to develop area graphs. Now let's move on quickly towards the last type of graphs, which are the pie chart. Okay, let me put in a few cells. So we will just show temperature, apparent temperature, humidity, and a lot of things for the first 10 columns. So for that, let me just show you that these are the first 10 values. So what we need after this is, now we need to develop pie chart for all of these columns. So we are not going to develop a pie chart for formative date, of course, or not for summary. We are going to develop pie charts for temperature, apparent temperature, or we can develop a pie chart for humidity. So first of all, let's develop a pie chart for temperature. To do that, the first thing that we need to do is we need to take a transpose of this. So a transpose of this data frame will look something like this. Okay, so we have an error. Let's see what this is. I did not enter dot here. Anyways, so this is the transpose of the data frame, and these are the 10 values here. So after this, the next thing that we can do is we can just take the value of temperature and plot it as a pie chart. So before that, okay, so to do that, let's just write df1 dot head, and it is for the first 10 values, and let's say that the we are taking only temperature. So TEMPARATURE, temperature, and in centigrades. So what is the type of plot? We are going to tell it now. Dot plot, just like before, and here we are going to enter all of these things. Kind is equal to pi, and after that we are going to enter fixed size. Fixed size is equal to 10 cross 20, let's suppose. After that, the next thing is we need to add percentages. So to add percentages, you need to just write this command here. So auto percentage is equal to percentage sign 0.1 and then two percentage signs. So it will make sure that you are adding percentages into your pie chart. After this, we will write that the start angle is something like 90, and we also want to have a shadow on our pie chart. So this is it. This is everything that you need to develop a pie chart for temperature. So now we are going to give it a title. So let's just copy that and let's just paste it here. And after pasting it, let's just say that this is the temperature overview, right? And this temperature overview is for a few days, only for 10 days. Let's write this and let's see what it gives us, if this works or not. Okay, so start angle, it is saying that it is invalid syntax. I think there is some mistake here. Let's see. Okay, so I have entered a comma here. Now let's see that this makes a difference, or is there anything else that's causing the problem. Okay, so that error is gone, but now it is saying that temperature does not apply. So yeah, in the temperature the C is bigger, that's why I always copy paste them. Okay, so after writing this bigger C, now we can see that we have plotted it for the first 10 days. The temperature is plotted here, and we have divided it into 10 different days, and the values are these. So on the first day the value proportion is 9.9, and on the last day the value proportion is 14.4. There are also a lot of things that we can do on this plot to make it look better. For example, we can get these percentages out of the box so that it looks better. Other than that, we can also add labels on any side. We are going to add it on the left side of this if we want to. So other than that, we can also write legend on a side, and we can also explode or distinguish some parts of this pie chart to make it look even more better. So to do that, the first thing that we need to do is we need to give it a good color list. So that will make sure that we have colors of our own choice too. So let me just copy paste the color list that I have decided before. So the colors that I would like to use are red, yellow, blue, orange, purple and pink. After this, the next thing is I should tell it which of the cells do I want to explode. So let's suppose if I want to explode three cells, first, fourth and fifth. So I will write explode underscore list here, and here I will write, let's suppose I want to explode the first one, then I will write 0.1, and if I do not want to explode the second one, then I will write 0, and not the third one, then I will write 0 again, and not the fourth one, then I will write 0 again, and if I want to explode the last two, then I will write 0.1 two times. So that is how I can do that. After this, we are going to take the transpose of our data frame. So let's take the first six values this time, because we have taken six colors. So for the first six values we are going to take the transpose in the same way that we did before, and after that the next thing that we need to do is we need to write the same commands for six values. Okay, so let's write 6 here, and let's do it for humidity this time, but I'll copy paste it so that there is no problem like before. Okay, So there we go. This is humidity, and this is the plot that we want. A few things that we want to add are, the first thing is we want to take the percentages out. To do that, we need to add PCT distance, which is percentage distance. So let's write the PCT distance is equal to, let's suppose something like 1.12. Okay. So other than that, there are, why is it showing it like this? Let's check it. Okay. So let's make it in the same line for now, because it is doing some problem. Anyways, the second thing that we can add in this is the color list. So we also need the color list. Let's add that by entering color is equal to color underscore list. So what else is there? We need to tell it about the explosion as well. So let's write explode is equal to explode list. So this is it. We have now explode colors distance of percentages, and other than that there is another thing that we need to add. We need to tell it that we do not need any labels. So let's write labels is equal to none. Okay, so these are all the things that we needed to add here. Let's see if it runs or not, but before that let's also enter a legend here. So let's write plt dot legend, and in the legend what we need is we need to use labels that are in df1. So we can just write df1 dot index in the labels here. Labels is equal to df1 dot index. There we go. And what should be its location? Its location should be upper left. So let's make sure that the axes are all equal. So let's write plt dot axis and write equal here, and let's see what it gives us. Maybe it gives us an error. Yes, because it is saying that the color list is not defined. So color underscore list is here. Let's just copy it and let's paste it somewhere here. Maybe there is a difference. Anyways, so it is saying in the same way that the explode list is not defined. Let's copy it, and yes, I did not write the hyphen here. So it is saying that the explode list is not defined. The next, okay, so it is saying that the color is an unwanted parameter. So the parameter is colors. Okay, so there we go. Okay, so this is it. We have taken out the percentages, and the percentages are not now shown outside of the graph. Other than that, we have made sure that we are exploding zeroth value, zeroth feature, and then the last two features. So we did that with the help of explode list. So this is the zeroth feature, and these are the last two features. So these are the last two features. It is saying that this is the temperature for the last 10 days. Other than that, these is the legend, which is saying that this is the zeroth day, 1st day, 2nd day, 3rd, 4th, 5th. So these are the 5 values which are showing the colors of the pie chart parts. So this is how you can use pie chart to develop your own graphs. So we have learned a lot about graphs and plots, and this is it for this section. In this complete course, we have teached you what is pandas, what is numpy, how we can do data manipulation, data sequences, data slicing, and all of these things with the help of pandas. After that, what we have done is we have shown you how you can showcase your data set that you have just cleaned with the help of pandas. And to showcase that data set, you need to have something like Matplotlib. So that's what we did in the second part of this course. So now this course is completed. In the next course, we are going to learn about machine learning and how we can develop machine learning algorithms after this. So until that, let's just say goodbye, and just click on the subscribe button and click on the like button as well. Thank you.